Hello students, today we are going to discuss about the shafts when it is subjected to not only torsion but also subjected to bending. So name of the topic is shaft subjected to combined bending moment and twisting moment. So twisting moment is nothing but the torque. Okay. So till date whatever 4 lectures we have studied, in that we have just considered the torque applied on the shaft. But now today we are going to discuss about the effect of bending also. Okay, means along with the torque, if there is a bending, what will be the effect on principal stresses? That is sigma max, sigma minimum. Okay, so there are some practical cases where sometimes shaft is not subjected to twisting but also subjected to bending moment M. Okay, means you might have observed the shafts of the trucks. They are rotating and transmitting the power, but suppose that is a free rotation and only subjected to torque. Suppose in addition with that rotation, if at the middle point of the shaft, if we apply some load in downward direction, that will cause bending in the shaft. Okay, means while designing the shaft, you should consider the bending stresses also. Okay, if there is application of bending moment on the shaft should not break. It should transmit the power very smoothly or easily. Okay, or such a shaft should be safe against bending also. So that's why specifically today we are going to discuss the effect of bending and torsion combined or combinedly or the shear stress and deformation, or we can say on the principal stresses. The stresses induced are combined effect of shear stress tau and bending stress sigma. Okay, what it means is, as you know that twisting moment or torque is responsible to develop the shear stress, and while bending moment M is responsible to develop the bending stress. Means shaft should be designed to resist shear stress as well as bending stress so that it will accommodate both the values of torsion as well as moment. In third unit, shear stress and bending moment and shear stress, we discuss all these 3 points. Or even in torsion, we know that shear in the torque by using the torsion formula T by J, G theta by L, tau by R. So we are not using here middle term, but T by J and tau by R. So these are the terms taken from the torsion equation. Okay. So here tau is equal to, we are interested to know the shear stress tau. So tau is equal to torsional moment T into R divided by G. Same formula. Okay. So this T into R will be equal to tau into G, and here J will be here coefficient for tau. Now it will be denominator here. So formula will be T into R by J will be equal to, and R is nothing but half of radius. Okay, distance of extreme fiber from center. Okay, radius, it is d by 2, and polar moment of inertia for cylindrical or circular section is pi by 32 d raised to 4. So here tau, by simplifying this, okay, so here it is d by 2 means this 2, it will be 16 here, this d and this d will cancel, it will be d cube here, and by simplifying you will get the 16 is denominator here, now it will be go on numerator here, it will be 16t, and this pi d cube, here it is a cube, pi d cube will be the term. So in this way you will get first term for shear stress, so tau is equal to 16t upon pi d cube. Okay, similarly find out the bending stress. Okay, using bending stress formula, we know that bending stress equation is m upon I sigma yy equal to E by R. So here we are using first 4 term, m upon I equal to sigma by y. So here we are interested to know the value of stress, bending stress. So sigma is equal to, again cross multiplication of this, and you will get the term m into y by I, and here we know that y is the distance of extreme fiber from neutral axis, it is d by 2, and it is moment of inertia here, it is pi by 64 d raised to 4 for circular section. Again by simplifying it will be 2 32 are 64, it will be half d cube here it will be, and then it will be 32 m divided by pi d cube. This is the formula for bending moment, bending stress acting on the shaft. Okay, now we know the magnitude of bending stress, we know the magnitude of shear stress here. Shear stress is known, bending stress is known, sigma. Okay, now you can use the equation of our simple maximum and minimum bending stresses. So what is our equation? When it is subjected to uniaxial stress, okay, only subjected to uniaxial stress. So sigma max or sigma minimum will be equal to, or it is also called as sigma P1, sigma P2. Why I have used both one here, P1 and P2, because here I have used plus minus. सिग्मा P1 वैलिड फॉर सिग्मा बाई टू प्लस, प्लस के लिए सिग्मा P1 वैलिड होगा, P2 के लिए सिग्मा बाई टू माइनस वैलिड होगा. ओके, दैट विल बी मैक्सिमम एंड मिनिमम वैल्यू. Okay, and we know that our formula is sigma x plus sigma y by 2 plus minus under root of sigma x plus sigma y by 2 square plus tau square. So here in the formula sigma y is assumed as a 0 because no stress in y direction. So that's why I have just considered sigma x and tau. Tau x को एक ही जगह आपको लेना है tau. So sigma x plus sigma y by 2. So sigma x equal to sigma y is 0. So this term will be sigma by 2. This will be also sigma by 2. And now put the tau is equal to. If you put tau is equal to here 16t upon pi d cube and stress sigma here. This is stress. This is stress. Sigma is equal to 32 m upon pi d cube. By simplifying, in every book this derivation is available. By simplifying, you will get this particular formula. And the formula is sigma P1 or sigma P2. Sigma P1, P2 is also called as the maximum principal stress. Sigma max or sigma P1 both are same. Sigma max, sigma P1 or simply sigma 1. Okay. So for all these three terms we are using the same formula, and normal and tangential stress, that equations are different. Okay. Sigma n and tau, that equation are different. There is no relation here. So here sigma P1 or sigma max will be equal to 16 pi d cube. By putting these two values in above equation, you will get 16 pi d cube in bracket m plus minus under root of m square plus tau square, m square plus t square. Okay, you will get the maximum stress here when there is a plus sign here. Okay, and you will get the minimum stress here when it will be negative sign here. So for sigma minimum there will be negative sign, sigma maximum there will be positive sign, the rest of the terms are constant. So in this way you should know the equation when you need to calculate the sigma max and sigma minimum when shaft is subjected to combined bending and torsion. Okay, or no need to write these equations, no need. Okay, you just write down sigma P1, sigma P2 or sigma 1 is equal to sigma by 2 plus minus. You find out the value of this term, put here instead of tau, find out the value of this sigma here, you put here instead of sigma, you will get the same answer. This is only the abbreviated form. Whatever equations I have written it will be in terms of t and m. Actually there is no need of this equation, put m and t, because for to count the effect of m and t we have proved the equation of shear stress tau equal to this 16t upon pi d cube and stress is equal to 32 m upon pi d cube. If you put these values, this equation 1 here, you will get the same answer by this, or you will get the same answer by using this. Okay. Now again, we have just calculated maximum and minimum stress. This is sigma max, sigma minimum. Now you need to calculate tau max also. So that's where the maximum and minimum stresses, principal stresses, maximum and minimum principal stresses, but you need to calculate maximum shear stress, tau max, and that is nothing but 16 pi d cube under root of m square plus t square. Either you use this formula or you can use this formula also, sigma p1 sigma p2 by 2, because here we know the value of sigma p1 and p2. If we use the same value here and if you divide it by 2, you will get the same answer by this and this. Okay, Even sometimes it is asked to calculate the equivalent stress acting on the shaft. Equivalent stress is nothing but the resultant stress, okay, and that is tau E will be equal to under root of m square plus t square. T is the torsion or twisting moment. T is not a shear stress. It is m and t are the moment and torsion terms respectively. So to find the equivalent stress, sometimes there may be problem for 2 marks. Moment and torsion or torque may be given in the problem, and they will ask you to calculate equivalent stress. In that equivalent stress, tau E equal to under root of m square plus t square. Okay. Now this is the third condition. Here you can see second condition. Now in the first part we have just discussed about bending moment and torsion. Now sometimes there is a chances of axial stress and bending moment. Okay, axial stress and bending moment along with the torsion. Okay, so at that time, you know that when rod is subjected to tensile stress, it will be uh, the direct stress acting along the x direction. That axial stress sigma a in the a direction will be sigma a p by a, where p is the applied force, a is the pi by 4 d square, and if this 4 is on the denominator, if you put it on denominator, it will be 4p upon pi d square. That is the axis stress. I have just transferred this 4 on the upward side. 4p upon pi d square. Here we will get the axial stress. Now to find the total stress acting on the element due to bending plus axial force, it is nothing but the addition. Sigma plus sigma A. Sigma is the bending stress. It is 32 m pi d cube. We have just seen in the previous slide. It is sigma plus sigma A is equal to 32 m upon pi d cube plus 4p square upon pi d square is nothing but the axial stress. It is the addition of sigma plus sigma A, and tau is equal to 16t upon pi d cube. Tau will be as it is. Okay. So in this way, for 2 marks again this problem is important. Sometimes axial stress may be given and they will ask you to calculate the total stress acting on the element. Okay. Now see the problem 1. A shaft of 95 mm diameter transmit 200 kilowatt power at 100 rpm. If at a section bending moment is 15 kilonewton meter, find the principal stresses and maximum shear stresses. Okay. So principal stresses means what? Sigma max, sigma minimum, or we can say sigma P1, sigma P2. So what is given term here? Here you can see given is the diameter of the shaft 95 mm. It transmit 200 kilowatt power. So it is 200 kilowatt means 200 into 10 to power 3 watt here. RPM means rotation n is given 100 RPM here, and bending moment is 15 kilonewton meter means 15 into 10 to power 6 Newton mm. Now first of all you should know the torque. The purpose of giving this data is to calculate the value of torsion or torque. Use the formula P equal to 2 pi nt upon 60. So in this equation all the terms are known except T. You will get the value of torsion by putting all these particular value, and torsion is 19.108 into 10 to power 6 Newton mm. Okay. So after getting torsion, you just use the formula for principal stresses. Okay. You use this formula or what I said before. You can use that formula of sigma by 2 by putting the value of m and t. By both the way you will get the same answer. So sigma p1 equal to sigma max. It is 16 upon pi d cube m plus under root of m square plus t square. Problems are very simple, but here you need to carefully put all these values. See the unit. Diameter is in mm, so moment also should be in Newton mm. Torque also should be in Newton mm. Means everywhere there should be power of 6. Okay. And by solving this, you will get the value of sigma p1, and for minimum value there will be negative sign here except this positive. All the terms are same. By putting all this value, you will get the minimum principal stress, that is sigma P2 minus 55.20, and maximum principal stress 233. Okay. After getting this minimum and maximum values, you calculate tau max. So tau max can be calculated using this formula, or you can directly use this particular formula. As a sigma P1 and P2 is not, sigma P1, sigma P2. It is nothing but the addition of sigma P1 plus sigma P1 minus sigma P2. So sigma 1 is sigma P2 is minus here, so this minus minus will be plus, and divided by 2 will get 144.30. Okay, even alternative method I have used. Alternative means what I said. So don't put this value tau and sigma in the formula. You just directly use this formula by finding out tau is equal to 113.51 and sigma is equal to 178.29. You just put this tau value and sigma in this above equation. You will get the same answer here. You can just verify. Just for the purpose of verification, I have just given this values. This is about problem 1. Now see the problem 2. A shaft of 100 mm diameter transmit 200 kilowatt power at 200 rpm. At the section, bending moment is 5 kN. Find the principal stresses, maximum shear stress, and angle of the principal plane. Now there is a mistake here. So here it is not a principal. PLE nahi hai, it is PAL. You make that correction. Everywhere in this chapter there is a no principal. PLE word कहीं पे भी use नहीं होगा. Everywhere you have to use this one. PAL, principal. That is correct word. Principal means, your meaning of principal means it is not a theorem or any law. Your meaning of principal is a major or a maximum. Okay, principal means what? Major force. Okay, or major stresses acting. Principal जैसे हम बोलते हैं कि important, like that. So it is just like I think previous problem. Power P is given, RPM is given 200 RPM, power P is 200 kilowatt. Okay, moment 5 kilonewton meter, so 5 kilonewton 10 to power 6. Here power use equation of power to pi nt by 60. Solving this, we will get the value of torque, that is 9.554 into 10 to power 6 Newton mm. Okay, so Newton mm, if it is 10 to power 3, it will be Newton meter, or it is also called as Newton meter is also called as a joule. Okay, you can use that word also. Again, you need to calculate same thing, principal stresses, that is sigma P1. Sigma P1 is nothing but sigma 1 or sigma max. You put all these values m and t. Here you will get the value of major principal stress 80.41. Similarly, find out minor principal stress. Only the change is here there will be negative sign. Everywhere all the terms and everything is same, only this sign will change for minimum principal stress, and solving this we will get the value of minimum principal stress minus 29.467 MPa. Okay, and maximum is 80.41, minimum is minus 29.46. Now to find out the maximum stress, you can use this formula also. Sigma P1 is 80, sigma P2 is minus 29. It will be plus, and by 2 you will get 54.94, or you can use this formula also. You will get the same answer by both the methods. Now in this problem they have asked us to calculate angle of principal planes also. So you know that for angle of principal plane we are having the formula tan 2 theta 1 equal to 2 tau upon sigma, or T by m. So tan 2 theta 1 equal to 9.554 by 5, 2 theta 1 equal to 62.37 by taking inverse of that this particular value. Okay, 9.554 by 5 करो, इसका inverse ले लो, आपको ये आंसर मिलेगा, and half of that will be the angle theta of major principal plane, and you know that second plane is at 90 degree. If first plane is here, second will be definitely at 90 degree. That is depends upon the sign convention. If it is positive in the direction of motion, if it is negative maybe in opposite direction. Okay, so here other principal plane will lies at an angle of theta 2, means here in the answer you have to add plus 90. Okay, you will get angle of other principal plane. Okay, so this is the angle of major principal plane, this is the angle of minor principal plane. This is about second problem. Now see the third problem. I think it is also just similar to previous problem. Steel shaft subjected to torque 20 kN meter. Your torque is given. You convert it into Newton mm. It is 20 into 10 to power 6 Newton mm, and bending moment of 10 kilonewton meter. So here bending moment m equal to 10 into 10 to power 6 Newton mm. Okay. The diameter of the shaft is 100 mm. So this d is 100 mm. Find the maximum and minimum principal stresses and maximum shear stress on the shaft. I think all the terms are near about similar to previous problem. You write down given things and put all these things here. Here diameter of the bar is also given as 100 mm. Okay. Here it is shaft is 100 mm. Yes, it is 100 mm. And solving this we will get sigma P1. It is 164.81, and by making negative sign here you will get minor principal plane, that is 62.95. So here I have shown both the value, minimum as well as maximum, and to find out the tau max use the formula, or you can use shortcut method, that sigma P1 of sigma P1 minus sigma P2 by 2. In that way also you will get the correct value of tau max. Okay, so you might have observed these type of problems are very simple to solve. Only you need to know the equation and proper conversion of all the values from one unit to other unit. Okay, so there is a more chances of happening mistake in conversion of values. So many times while assessing the papers, we observe that you are making mistake in either unit of sorry, conversion of value of moment or torque or in diameter, all these things. So you should have the practice of all these type of problems. One problem will be there in your final examination. So do the good practice of this particular content, and after share, when I will share the PPTs, write down carefully all these things in your notebook as a note. Okay. You go through the videos. You can also go through the YouTube videos for additional information. Okay. So during the explanation, it may happen that many things I might have missed. So for clear understanding of the particular topic, you can go through the similar type of videos on YouTube that is available from IIT professors or NPTEL teams. Okay, so go through the videos also and write down all these things in your notebook. Okay, so I will stop here. Thank you very much.